Hello students, welcome to my channel Grow in Maths. In this video you will get how to find the derivative of some function by using log. Okay, our first problem is y equals to log x to the base a. Okay, we know that ddx of log x to the base e equals to 1 by x. Okay, we know this formula. Now to get this form we have to change this base, so we have to write or y equals to log x to the base e into log e to the base a. As we know the formula for log, that log a to the base b into log b to the base c equals to log a to the base c. So by using this formula we can write log x to the base e into log e to the base a. Okay, then log e to the base a is one constant. Now we have to take the differentiation in both sides. We have to write therefore or differentiating both sides with respect to x, we get, therefore if we take the derivative of y, that time we are getting dy dx equals to, here log e to the base a is a constant, so log e to the base a and ddx of log x to the base e, so the derivative of this will get 1 by x, so 1 by x into log e to the base a, and this one is our required dy dx. Okay, our next problem, find derivative of log of sin x to the base x. So at first we have to take it as y, so we have to write let y equals to log of sin x to the base x. Okay, as we have already known that log of x to the base e equals to 1 by x, so we have to get the base as e. So like previous one we have to write or y equals to log sin x to the base e into log e to the base x. Okay, as we have done in previous problem, but here we have to do one more step, or y equals to log sin x to the base e into 1 by, as we know that log a to the base b into log b to the base a equals to 1, therefore log a to the base b equals to 1 by log b to the base a. So if we just take the inverse of this, that time we will get log x to the base e. Okay, therefore we are getting y equal to log of sin x to the base e, and here the denominator as log x to the base e. Okay, let me see it once again, that at first we have log of sin x to the base x, so to change the base we have taken log sin x to the base e into log e to the base x, and later we have to take the inverse of this, then we got that 1 by log x to the base e, and now finally a into 1 by b means a by b, so we got y as u by v. Now we have to apply the formula for u by v. As you know, the derivative of u by v is given by v square, then v du dx minus u dv dx. So we'll just use this formula. Now we have to write differentiating both sides with respect to x we get. So the left side we are getting dy dx equals to, here v square at first, so log x to the base e whole square, then we have to write v here, means log x to the base e, then ddx of u, du dx means ddx of u means log of sin x to the base e, minus, now u we have to write, means log of sin x to the base e into ddx of log x to the base e, that is dv dx. Okay, now we have to take the derivative of u and v, log x to the base e into, here we have ddx of log sin x to the base e, so we have to think this one as x, so log ddx of log x to the base e means 1 by x, and as we have taken sin x as x, so ddx of sin x into ddx of sin x minus, here log of sin x to the base e into ddx of log x means 1 by x. In denominator we have log x to the base e whole square, log x to the base e, here ddx of sin x means cos x, so we are getting cos x by sin x minus 1 by x log of sin x to the base e. So we are getting log x to the base e cot x minus 1 by x log of sin x to the base e and log x to the base e whole square. Now if we take the LCM of this x, that time this x will come here at the denominator, x log x to the base e whole square, x will be multiplied with this x log x to the base e cot x minus log of sin x to the base e. So this one is our answer, x log x to the base e cot x minus log of sin x to the base e by x log x to the base e square. Now we have this following problem, find derivative of log of root over 1 plus sin x by 1 minus sin x. So at first we have to take let y equals to log of root over 1 plus sin x by 1 minus sin x. Okay, or y equals to, at first we have to simplify this function, so root means 1 plus sin x by 1 minus sin x whole to the power half, and as we know log x to the power n to the base a equals to n log x to the base a, means that power will come at the front, so we have to write, or y equals to half log of 1 plus sin x by 1 minus sin x, this power has come here, or y equals to half, now we have log m by n, log m by n to the base a, it means log m to the base a minus log n to the base a, so we can write within a bracket that log of 1 plus sin x minus log of 1 minus sin x, here 1 plus sin x is our m and 1 minus sin x is our n. Now we can write differentiating both sides with respect to x we get dy dx equals to half. Here we have to think 1 plus sin x as x, so we have log x. Derivative of log x is 1 by x, means 1 by 1 plus sin x, and as we have taken 1 plus sin x as x, so ddx of 1 plus sin x, minus here also this one is our x, so 1 derivative of log x is 1 by x into ddx of 1 minus sin x. Okay, half. Now 1 plus sin x and ddx of 1 0, and sin x is cos x, minus here 1 minus sin x, here the derivative of 1 is 0 and ddx of minus sin x is minus cos x. So half. Now this minus minus become plus, and we can take cos x common, then we are getting 1 by 1 plus sin x plus 1 by 1 minus sin x. Now I have to take the LCM. LCM become 1 minus sin square x as 1 plus sin x into 1 minus sin x, and numerator 1 minus sin x plus 1 plus sin x. Sin x cancel, getting half cos x into 2 by cos square x. 2 cancel, 2 ones are 2, and 1 cos x also cancel, so you are getting 1 by cos x, it means sec x. So this is the derivative. Okay, now we have this one. Find derivative of x cube root over of x square minus 12 by cube root of 20 minus 3x at x equals to 4. So at first we have to write let y equals to x cube x root over x square minus 12 by cube root of 20 minus 3x. Then we have to simplify this function, and to simplify it we have to take log in both sides. So I have to write taking log with respect to base e in both sides, we get, okay, so log y equals to log of this function x cube root over x square minus 12 by cube root of 20 minus 3x, or log y equals to, here we can think that this one is m, this one is m, this one is n, and this one is our p. Okay, m and p, log m and p. So if we have log m and p, that time we can write it as log m plus log n, and as we have this in denominator, so minus log p. Okay, equals to, now the power will come at the front, so 3 log x, then for root we have half log of x square minus 12 minus, here cube root means in power we have 1/3, so 1/3 will come here, and log 20 minus 3x. Okay, this one is our log y. Now we have to write differentiating both sides. Both sides with respect to x, we get, here we have to take y as x, so log x, the derivative of log x is 1 by x, means 1 by y, and as we have taken y as x, so ddx of y means dy dx equals to, here 3 by x plus half, here we have to take this one as x, so x square minus 12, and the derivative of this means into 2x, minus 1 by 3 into 1 by 20 minus 3x, and derivative of this is minus 3. Okay, therefore dy dx equals to y will be multiplied this side. Y, the value of y we have to write once again, x cube root over x square minus 12 by cube root of 20 minus 3x, then within bracket we have 3 by x plus x by x square, here 2 to cancel, x square minus 12, here minus minus plus 3 cancel, 1 by 20 minus 3x. Okay, now to get the value, we have to get the value at x equals to 4, so I have to put x equals to 4 at dy dx. Therefore dy dx at the point x equals to 4, if we put 4, that time 4 cube means 64, and here 4 means 16, 16 minus 12 means 4, root over 4 means into 2, here 20 minus 3 4 12, 20 minus 12 8, cube root of 8 means 2, then we have 3 by 4 plus 4 by 16 minus 12 means 4 plus 1 by 20 minus 12 means 8. Okay, now can cancel 2 1s are 2, 64, and here the LCM becomes 8, so 6 plus 8 plus 1, and now 8, so we are getting actually 8 into 14 plus 1 means 15, that is 120. So we got the value of dy dx at the point x equals to 4 as 120. Now we have this, find dy dx for y to the power x plus x to the power y equals to a. We have to write given, here already y is involved in this given equation. Okay, and we have to get dy dx, given y to the power x plus x to the power y equals to a. Here we have to use one formula from logarithm, that is e to the power log m to the base e equals to m. Okay, how to prove? Let log m to the base e equals to x. From the definition of log, then we can write m equal to e to the power x. Therefore m equals to e to the power, what is the value for x? The value for x is log m to the base e. Okay, so we can write m in this form, e to the power log m to the base e. Okay, so as here we have variable to the power variable, here x is variable and it is on y here also, and between these two we have plus, so we have to use this form. Otherwise if we have monomial in both the sides, that time we can take log in both sides and then we can differentiate, but here we have binomial and both having power as variable and the base is also variable, so we have to use this. Let's see how we can write. This one is our m, so we have to write e to the power log y to the power x, and here base e no need to write, plus e to the power log y x to the power y equals to a. Or now this power of y will come at the front, so e to the power x log y plus e to the power y log x equals to a. Now we have to differentiate. we get e to the power x. The derivative of e to the power x means e to the power x, e to the power x log y, and we have taken x log y as x, so we have to take the derivative of this. Derivative of this we may write once that d dx of into, as we have taken this one as x, so e to the power x, derivative of e to the power x is e to the power x, and then d dx of what we have taken as x, x log y. Same here, that derivative of e to the power whole thing as x, so e to the power x, then d dx of what we have taken as x equals to the derivative of a is 0. Okay, now or now see, e to the power x log y means e to the power x log y means e to the power log y to the power x, it means y to the power x. So for this function we can write y to the power x directly, and now we have to differentiate this. So at first keep x and think log y as x, so log x, derivative of log x is 1 by x means 1 by y into, as we have taken y as x, so dy dx, plus now the derivative of x is 1 and keep log y unchanged. Here also e to the power y log x means e to the power log x to the power y means x to the power y only, so we can write x to the power y, and then within bracket we have to take the derivative of this, means at first we keep y, then log x, derivative of log x 1 by x, plus now dy dx, the derivative of y, and keep log x unchanged equals to 0. Now we have to multiply thoroughly. Here we'll get x into y to the power, here y to the power x, and here y to the power 1, so a to the power m by a to the power n means a to the power m minus n dy dx, plus y to the power x log y, plus here also same thing, x to the power y minus 1 into y, plus x to the power y log x dy dx equals to 0. Now we have to keep these two terms in the left by taking dy dx common from them, so x y to the power x minus 1 plus x to the power y log x dy dx. See, x y to the power x minus 1 plus x to the power y log x dy dx equals to, if we take these two terms on the right side, that time they become minus, so taking minus common from them, y to the power x log y plus x to the power y minus 1 into y, and finally our answer, therefore dy dx equals to minus, here we have in the numerator with y to the power x log y plus x to the power y minus 1 into y by x y to the power x minus 1 plus x to the power y log x. So this is our dy dx from the given function. Okay, thank you students, hope this video will help you to understand how to use logarithm to get the derivative.